Welcome to the Insightful Professor. Today we continue our examination of the Java programming language, and we're going to talk a bit about how to compare string objects. When you compare objects, it's a bit different than comparing two variables or two values of a primitive data type, such as integer. What happens is you formulate an expression with primitive data types where what you're doing is specifying one variable or one value, then the relational operator, and then finally a second variable or value. This is what we call infix notation. The operator is placed in between the two operands, the two things being compared. So this is relevant if we're using variables, values, or a combination of the two, provided that this is a primitive or built-in data type. Now recall that Java has 8 such built-in or primitive data types. So if you're programming with any of those, we use this infix notation. But when you're programming with string objects or objects in general, and you wish to compare one object to another, what you have to do is you have to invoke a special method. The method must be known to the class with which you're working. The way you do this is you invoke the method by using one of the objects to provide a context. So that object, its reference variable, is used to qualify the call to the method. For example, if we have some reference variable called ref obj1, and that refers to, say, a string object, then ref obj1 dot equals would be providing the context for the invocation of the equals method. This is how we call the equals method for object 1. But remember, this is a binary operation when we're comparing for equality or any of the other relational operators. So therefore, object 1 must be compared to something else. So how do we bring in the second object that is involved in the comparison? Well, we do that by using the second object as an argument to this method that we're invoking. So reference object 1 would be the reference variable to the first object. Reference object 2 would be a reference variable to the second object. Reference object 1 is used with the dot notation or the dot operator to qualify the call to equals, and then ref object 2 is passed as an argument to that method. You can see that the syntax here for such an expression as to how we actually make the call to do the equality test is quite different than what we do with variables of a primitive data type using the infix notation. So that's the tricky part of this, getting used to that particular form. Equals is actually defined for us already with the string class. So if we instantiate objects of the string class, we're freely able to use the equals method. It's already been defined. But what's interesting is if we define classes of our own, user-defined classes, we can provide an implementation of the equals method, and we can then follow the same procedure that we're going to be describing and discussing in some detail in this video with respect to string objects. It's important to understand that strings are objects. So when we declare a variable of type string, we're really declaring what's called a reference variable, something that is referring to that particular object. And we can then use that reference variable to qualify calls to methods to something such as equals. Relational operators cannot be used with object variables or reference variables to perform some kind of a comparison of the objects. We must use the method. In this code segment, we're declaring a reference variable called greeting, which will point to a string object. Likewise, greeting2 will point to a string object. We've initialized these objects with different values. You can see that what we have here is an uppercase H in the word hello, and in greeting2 we have a lowercase h. Remember that each character has its own internal representation in some binary format. So what happens is there is a distinct difference internally within the computer between a representation of hello spelled with an uppercase h and hello spelled with a lowercase h. So these two strings, as we see them expressed here, are different from one another. How do we actually compare these? Well, we're using the reference variable of greeting and of greeting2. Again, following the convention or the syntax that I discussed in the previous slide, we would say greeting, use the dot operator, invoke the method equals, and then we can pass the second string. Now, in this case, what we're passing is a string that has the same exact value as that being pointed to by greeting. So this should come up with a value of true. The point is that equals is a Boolean type of function. It returns a true or a false, which makes sense. If we're saying this is equal to that, it is either true or false as we make that claim or make that inquiry. In the second situation, we're using greeting once again, which contains the uppercase version of the hello, and we're comparing it to this version of a string called goodbye. And not surprisingly, this expression will return a value of false. And finally, we compare greeting with what's being pointed to by greeting2. And as we can see from our display, they're not equal, and sure enough, this should return a false for us. To see the complete program in action, we have the code in a file called comparestrings.java. We'll take a moment and look at my IDE and actually run the program to confirm the behavior that I just presented. So I've loaded into the IDE the Java code for the compareStrings class. And you can see that on these first couple of lines, I've declared the two reference variables for the string objects that we were discussing just a moment ago. So we have greeting is pointing to or referring to the character string hello spelled with an uppercase H, and greeting2 is pointing to or referring to the hello string with the lowercase h. Here we're invoking greeting.equals, comparing hello with uppercase to this other string hello with uppercase. And again, we're saying this should return a true. And then the other two we've already discussed. Let's go ahead and fire this up and see if it does agree with our discussion a moment ago. Let's look at what we have here. And what we see is the first call produces true, just as advertised. The second call produces false. And remember, what we're comparing there is hello with goodbye. And clearly they're not the same. The way it works, the way the method actually executes, is to compare character by character using the Unicode representation of the characters as stored in memory. And it proceeds on a character by character basis until it exhausts all of the data in the strings being compared and concludes, well, the two strings are equal. Or what happens is it finds there's some difference, and at that point it aborts or terminates the comparison and draws the conclusion of one string being less than or greater than the other. And finally, the third call here, which was to equals using greeting and greeting2, came back false as well. We're going to take a look at this in just a moment, but there is a second method that's available. What's interesting is when we compared hello, spelled with uppercase h and lowercase h, we might have thought, well, that looks good enough, it's close enough that they should be treated as equal. It turns out that clearly they weren't, and the explanation was just given, that it's done on a character-by-character basis. And as it looked at the uppercase h and the 1 and 0, the binary configuration, that was different than the 1 and 0 or binary configuration for the lowercase h. Thus, the two strings were deemed to be different. If we wish to ignore the case and simply say, I'm looking for essentially the letters being the same, I don't care if they're uppercase or lowercase, do these two instances both spell hello? That's all I want to know. Then I can invoke this method called ignore case. So here we're looking at greeting2 and greeting being compared. That's the hello with the two different forms. And notice it comes out true when we invoke the equalsIgnoreCase method. And likewise, here's greeting, which we know contains the uppercase version of hello, and we're comparing it to the lowercase, and once again, the case is ignored, and it's in essence the same thing. So that's the basic idea on comparing strings for equality. Let's go back to the presentation and examine some more details of our comparison. Although I've already brought this to your attention, for completeness, I'm going to present this slide to take a look at the description of equalsIgnoreCase. You can take a look and read this description. It should agree with what I just presented to you. And here's the code that we extracted from the program that we just ran. The next thing I want to do is show you one other interesting little point here. We're going to take a look at another program called CompareStringsBad.java. And the explanation of what's happening here will become clearer once we take a look at the code. Remember, we have to invoke these methods to perform the actual comparison. We cannot use relational operators. This code for CompareStringsBad is going to attempt to use the relational operator with the reference variables. So let's take a look at how the system is going to react when we attempt to do that. So we have our two strings. We have str1, which points to this character string here. Java strings are objects. String 2, if we read it, it sounds the same, but clearly as we look at it on a character-by-character basis, which is how a comparison is made when we invoke the equals method, we see that one word starts with uppercase s and the corresponding word in the other string starts with lowercase s. And likewise, the same is true for these last two words. So clearly, we know that these should not compare to be the same. So we can go ahead and say, let's look at compare str1 equal to str2. Try to use the infix notation with the relational operator that we've become accustomed to using when working with numeric variables or variables of the primitive data type. So we try to use it here, but what happens is something a little different. Go ahead and run this and see what we get. And it says what? The variables str1 and str2 do not reference the same object. What does that mean? Well, it means that this guy down here is what is being executed, right? This print line versus this first print line, which means it took the else, which says what? str1 equal str2, they're not the same. Well, we might be deceived into thinking, well, it meant the two strings aren't the same. But in reality, what it means is the address or the reference within the variable str1 is not the same as the address or the reference within variable str2. That is, the two variables are pointing to different things. It doesn't say anything about the values of what they're pointing to. So it's kind of a mistake to be led down this path and believe, oh, because they're different values, that's why we took the else. Well, it's not different string values, it's different address values, or different pointer values, or different reference values. So you want to be clear on that point. Let me go back to the video and show you a little graphic that will hopefully make this point much clearer. Okay. Take a look at the concept here of declaring str1 as our string reference variable, and we give it the same string that we just saw in the code a moment ago. This is what happens. str1 is a reference variable. The reference variable gets populated through this assignment operator with a pointer or a reference to somewhere in memory where the object actually resides. If we go ahead and create the second string object and string reference variable, as was done in the code, remember we're using a different value here, but what actually happens is the str2 reference variable gets created and points to a different memory location. The two memory locations could contain the same value, but what happens is str1 and str2 are pointing to different locations. So it's possible the same value could be stored in multiple locations, and str1 could be pointing to one of those locations and str2 pointing to another location. That's what was compared when we said str1 equal str2. So that's why we want to use the equals method. Keep in mind there was another instruction in the program which we kind of ignored. You may have seen it. I didn't pay any attention to it or bring it to your attention. But there's a third variable. And we create this by assigning that. Remember, this is the assignment operator, not the relational equal operator. We assign to it what's in str1. What we are actually assigning is shown here. str1 is pointing to some memory location with this particular string object at that memory location. The result of declaring a new variable and assigning to it what's in str1 is to take a copy of the memory location that str1 contains, and now that makes str3 point to the same memory location. So think about this for a moment, and hopefully this will make sense to you. And I believe this illustration makes it a little bit clearer than simply talking about the idea of reference variables and so forth. So take a closer look at this one. Remember, we just emphasized the point that this is an assignment operator, not an equality relational operator. If we use the assignment operator here, perhaps out of force of habit, because for many years we've been using a single equal sign to represent a test for equality. But remember, in Java, you require two equal signs as the relational operator. If you use a single equal sign, this is the assignment operator. This actually causes a problem in the code when we attempt to compile it. This doesn't make any sense, because this is actually an assignment, but we've put it or placed it within the context of where there should be some kind of a relational expression. And what happens is str1 assigned str2 really doesn't evaluate to true or false. So that doesn't really make any sense here. So that's why we might get slapped on the wrist and get a compile error. Okay, and the explanation is given here. The contents of a string object is said to be immutable. We cannot change it. So once the string object has been brought into existence, the actual object itself, its value cannot be altered. So the following assignment statement actually doesn't alter say an object. What it does is it alters the contents of a string reference variable and makes the two reference variables now point to the same location. But it also raises another interesting concept. str1 previously might have been pointing to another object somewhere in memory. But after this instruction executes, both str1 and str2 contain the same reference or address or pointer. They're now pointing to the same memory location. So what happened to the thing that was being pointed to by str1? Well, if str1 is the only pointer or reference variable that we had in our program that contained that address, str1 is no longer pointing to that address, which means we now no longer have a way to get to that location and access the object. What we have created, using this very technical term here, is garbage. That's actually what is referred to as memory, for which we no longer have the address or a reference. We can no longer get to that memory location. In some programming languages, such as C++, we actually would have to periodically somehow do garbage collection to reclaim that inaccessible memory. But Java uses what's called automatic garbage collection. We don't really have to give much concern to the idea of generating garbage and subsequently reclaiming it. It happens automatically. But you want to be aware of this notion of how garbage is generated. So we have another example out there called Immutable Strings.java, which contains a complete example of some of the code we've just taken a look at. So let's go and take a look at that in the IDE and see how that behaves. Okay, here we are with the code called Immutable Strings. The example is just slightly different than what I presented, but the concept is exactly the same. Here we have a variable called greeting, which contains a reference or pointer to the string hello world, and then we have greeting2, which contains a reference or pointer to another string called hi there. And what we do is invoke the printline method, sending to the console whatever greeting2 is pointing to. So we'll get a display of hello world, and subsequently greeting2, and we'll get hi there. Then comes the assignment. Here we take whatever greeting is pointing to, we take that address or that pointer or that reference, and we copy that reference into greeting2. The result would be that now if we follow the reference from greeting, we go to the same memory location that we go to if we follow the reference to greeting2. Both reference variables now point to this hello world object. We've lost the access to hi there. Therefore, that will become garbage, and the memory allocated to that will have to be reclaimed by the system. And this will be done automatically with Java's automatic garbage collection. So after we've made this assignment, we then display the content, not so much the content, but what the two objects are in memory by following their pointers or references. So let's just run this to confirm the behavior. So we get hello world, the output of the first call to print line. We get hi there, the output of the second call to print line. We do the assignment, and after that, we show what greeting is pointing to and what greeting2 is pointing to, and lo and behold, they're pointing to the same exact thing. We've lost access to hi there, garbage. But by now, after some period of time, due to our automatic garbage collection, that memory has been reclaimed and is available for reuse. By the way, another term for this garbage that gets created is sometimes we call it a memory leak, because the memory is effectively lost for our access within the application. And if you have enough memory leaks and there's no reclamation, no reclaiming of that storage, what happens is the system might come to a screeching halt. With Java, that should not happen due to automatic garbage collection. But it is something you want to be aware of. In an effort to provide a more complete or comprehensive description or discussion of comparing strings, we turn to one more statement that Java supports, the switch statement. Recall that what the switch statement does is it takes some kind of a value or an expression and allows you to present a series of values that are compared against what that value or expression evaluates to, and then control the flow of execution within your program. Prior to the Java Development Kit version 7, switch operated only on numeric data, say only on an integer type. Int or char would be acceptable. Char technically is a number. What that meant was if you were dealing with strings, you had to do your comparison and do the control flow for the execution of the program by using an if-then-else type of structure. You could not rewrite it using a string. It turns out that we are now able to use the switch statement with a string, which makes it much more flexible. So the point here is that the if-then-else type of structure, or if-else-if structure, presents kind of a ladder. Although semantically correct, the switch statement might seem to be a more natural or intuitive way to perform the series of evaluations, make a selection as to which block of code should execute. So this may enhance the readability of your code by being able to use string with a switch statement. So here's an example. We have a string reference variable, which has been assigned the address or the pointer or reference to the string with the word cancel. The switch statement checks the value of the string and compares it to this string. Are the two strings equal? If so, execute this block of code. If not, compare this. If the two strings are equal, execute this block of code, and so on. And again, we could have a default block, and we could have several other case labels if we wish to. The point, though, is we're doing the compare almost like we were doing it with integers and other data types without the need to use the equals method. So that's pretty interesting. The complete code is available in stringswitch.java. And we can take a quick look at that. And here's the code. And we'll fire it up just to show you the behavior. Again, we are testing for cancel. And sure enough, it says canceling, which is the instruction that was specified to execute if we found a match with cancel. And I'll just confirm that for you by revealing the rest of the code. And sure enough, that had to be the routine that executed. To summarize what we've just discussed, we say a string is an object, so it's accessed through a reference variable. Relational operators cannot be used to compare strings. If we use them to compare strings by using their reference variables, we're actually comparing addresses or memory locations, not the actual objects themselves. So we have to use a method. And the two methods that we discussed with the string class would be equals and equalIgnoreCase. And just a reminder that equals can be implemented in user-defined classes. And again, as of Java Development Kit version 7, the switch statement supports comparison of strings. To find the files that we just introduced, you can find that on my website, www.timhartley.com. Just follow the Insightful Professor link. Hopefully you found the video to be helpful and informative, and if you'd like to offer some comments, just leave those in the comments section below. And consider subscribing to the channel to be made aware of when we post future videos. And once again, thanks for watching.